So, and that means in your class, we left off, we've done the top 2 sets of examples. So we described and graphed an inequality, and then we took a description and we wrote the inequality and the graph. And now, on this bottom set, we have an inequality, we have a couple interval notations, but we're going to take these, we're going to convert these from interval notation to inequality or inequality to interval notation. Okay? So we're trying to go back and forth. Officially, you don't have to graph this. However, I will say a graph is kind of my teaching tool. Okay? So with that in mind, I would suggest that you graph if you're trying to figure it out. So right here, we have interval notation from -6 to 3. We need to write that as an inequality. Now, do you know what that interval notation from -6 to 3 means? What does it mean?
That, it's like, do you want the inequality? Or
You can give that a try if you're ready.
-6 is greater than or equal to x, which is, or no, sorry. -6 is less than or equal to x, which is less than 3.
Okay, I can go with that. Okay, if you're kind of hesitating, like, I don't know where to start. This is just kind of an unofficial graph. What does the graph for interval notation of -6 to 3 mean? It says we start shading at where? -6, and then you finish shading at 3. -6 has a bracket and 3 has a parenthesis, yes? Okay, now, inequality then. This is that whole idea of it's all the numbers between -6 and 3. I showed you yesterday when you're writing it's all real numbers between, put your x or your variable between the 2 numbers. So x is between -6 and 3. The easy one is, this is less than 3, isn't it? Everything to the left of 3. So I'm just going to use a less than sign. It's not equal to because that is a parenthesis. And remember, parentheses are not included. Now, over here, I would normally say it's x greater than -6. It's to the right of -6. But in my expression, my x and -6 are flipped. So I don't get to say x greater than -6. I say -6 is less than x. And specifically, this is a bracket, which means we say less than or equal to. Okay? In a typical expression like this, when you put x in the middle, if it's shading in between the numbers, which is the only time we can use this expression, you have the smaller number on the left, the bigger number on the right. These will always be less than symbols. So -6, less than or equal to x, less than 3. Does that make sense? Okay. Think about B. And if you're not sure where to begin, I'm going to say sketch a graph in your head. It doesn't say you have to do a graph, but I'm going to say just kind of sketch a graph. Where is this? -infinity and -1 says my shading is where? Yeah, it's shading from -infinity to -1. And there is a parenthesis there. So now if you're writing a basic inequality, what is that? That's all numbers that are what? Where are they in relation to -1?
Less than.
They are less than -1, yes? So I'm going to write this as x less than or equal to? Just less than because it's a parenthesis. I don't remember. Does the pre-calc book do like -infinity, less than x, less than -1? Or is that my Algebra 2 book?
I can tell you I don't have one.
You have access to one now.
I'm working on it.
Okay. Now, because you could You could see them try and do it fancy like that. I don't want that, where it's negative infinity, less than x, less than -1. It's saying the same thing. It's just saying that x is between -1 and negative infinity, but I'm happy with what's boxed, okay? We don't need to get that fancy. Okay, C. They give us the inequality. Now we're writing interval notation. Well, -2, less than or equal to x, less than or equal to 3. Can you visualize what this graph looks like? If we look at this piece right here, this is saying what? X less than or equal to 3 says all numbers where?
Left.
Left of 3. What about this piece here? -2 less than or equal to x. Well, if I flip that, that is x greater than or equal to -2. So that's saying what?
To the right.
To the right of -2. Again, what is this like that we did earlier? This is all numbers between them, yes? So, with that in mind, I want interval notation. Where does my shading begin?
-2.
-2. Bracket or parenthesis?
Bracket.
Bracket because it's n equal to. Where does my shading end?
3.
3. Bracket or parenthesis?
Bracket.
Bracket because it's equal to. Okay. When we get to homework time, I will kind of review a couple of directions with you. Make sure you read the directions carefully about what they want. You know, do they just want one thing? Do they want a couple of things? I feel like in some of the directions, if I recall correctly, they want a couple of different things. So you'll want to read the directions carefully on these sections. But it's just trying to get you re-familiar with all this, going back and forth, knowing what's what. Okay. In Algebra 2 today, I wrote up on the screen which one's less than, which one's greater than. Do we need that? Do we remember? There's my less than, right? Looks like a sloppy L. There's my greater than. You've got to just know those. I told my Algebra 2 students that today. You've just got to know those. Okay? Hopefully we do at this point. Okay. Got it? Okay. The bottom of this page has 2 sections. One, it has some properties. These are properties that I think you've probably literally been talking about since early elementary school. Okay? Commutative property. X plus y equals y plus x. That's just saying that 2 plus 3 is the same as 3 plus 2. You can add either way. Now, keep in mind, that is, right there, they're demonstrating commutative property of addition. It also works for multiplication, yes? Commutative property of multiplication works also, where x times y equals y times x. When you give properties in homework, and I'll remind you of this when we get to homework time, don't just tell me, because you have some to identify, don't just tell me commutative property. Is it commutative property of addition or multiplication? Okay, so be able to say which one. Associative property. I always think of the associative property. This is the associative property of adding. There's also multiplication. You're adding 3 things. The order stays the same. What changes? The parentheses, the group. This is saying you can add y plus z and then add x. And that's the same as adding x plus y and then adding z. But in an associative, same order, x, y, z, my parentheses move. Could be the same thing with multiplication. X times y times z, you could have parentheses around the yz. X times y times z, parentheses around the xy. So there's associative property of addition or multiplication. Distributive property. Old news? What's the distributive property doing? It's taking something that is either out front of a parenthesis or it could be out back of a parenthesis and it's distributing it into the pieces being added or subtracted in the parentheses, right? So that's your distributive property. Okay, identity properties. There's two. There's identity property of addition and of multiplication. Identity property is what do you do to a number to keep it the same? What do you add to x to keep it x?
0.
You add 0. So your identity property of addition is adding 0. That keeps it the same. What do you multiply x by to keep it the same? You multiply something by 1 to keep it the same. So your identity property of multiplication is multiplying something by 1 and it stays the same. And then the last one is the inverse property. Inverse property is basically what do you do to get these identities. So the addition identity is 0. What do you add to x to get 0? And you're adding the opposite, right? The negative. So if I say, what do I add to 5 to get to 0? I add negative 5. Okay, so your inverse property of addition, you always want it to equal 0. Well, what was our multiplication identity? It was 1. So what do we multiply by a number to get 1? So what do you multiply by 5 to get 1? Or here it's what do we multiply by x to get 1? Let me ask it easier. What do you multiply by 2 to get 1?
Oh.
0.5.
Okay. Which is what as a fraction?
1/2.
1/2. Okay. So the idea here is 2 and 1/2, they have what relation? 2 as a fraction is 2 over 1. 1/2 is
1 over 2.
1 over 2. When right here, someone's getting an important phone call back there. Geez. Okay, so right here, this is saying x times 1 over x. Okay. X times 1 over x is equal to 1. So it's just saying a number times its reciprocal, basically, is going to equal to 1. That's what that x and negative first is saying. Okay, so those are your properties. In homework, you'll see a section where they just give you an example and they want to know what property is being demonstrated. Okay? Exponential notation, old news, a to the power of m. A, vocabulary, a is the base and m is the exponent. You might hear the whole expression, a to the m, called a power. Okay? Okay, properties of exponents. I just need you to know these. You've been doing this since probably middle school. We have to know our properties of exponents. Okay, we have to be confident in these. U to the m times u to the n. We reviewed these second semester algebra 2. I think it was second semester. If you're multiplying and the bases are the same, what do we do with the powers? You add them. So if you're multiplying the bases the same, keep the base, add the powers. Over here, you have a similar thing with division, right? If you're dividing and the bases are the same, keep the base and subtract. Okay, so know these powers, or these rules. Now, if it's a power raised to a power, so if you just have one base, and it's a power raised to a power, we're going to take these powers and multiply. This one right here, if there's kind of two bases, uv to the m, this just says that the m has to go on both pieces. It's u to the m and v to the m. And that works as long as it's just pieces multiplied inside. This also works with division. If it's u divided by v, this m goes on numerator and denominator. So u to the m and v to the m. Anything raised to the power of 0 is always 1. Know it. If you forget it, your calculator will remind you. And how do we deal with negative exponents? This is a huge one. How do we deal with negative exponents? You get rid of the negative exponent, you take it to the denominator, right? You take it across the fraction bar. If that negative exponent happens to be the denominator, you take it to the numerator. These sound familiar, right? Okay, well, we're going to practice with them. Next page. Oh, scientific notation. We'll have some scientific notation examples down here also. C times 10 to the m. Keep in mind, if something is truly in scientific notation, C has to be a number between 1 and 10. It can be no smaller than 1.0. And technically, it can be no bigger than 9.999999999. You know, technically, it doesn't get to be 10. So it's any single digit number type thing. Could have decimals, but. And then m has to be an integer. So it has to be a positive or negative whole number. You can't have a fraction or anything in the exponent. Okay. So exponent talks here. Identify the base and exponent of negative 3 to the 5th. What's the base? Negative 3. What's the exponent? The 5. Okay. B. Usually you're going to read that the same way. Negative 3 to the 5th. What's the base?
Negative 3.
Disagree?
3.
The base is technically only the 3 because there's no parentheses. What's the exponent? 5. Now, mathematically, do these give me the same answer?
No.
Actually, in this case, it does. Would it always give me the same answer, depending on what you have in there? Okay, so what, just review, what does negative 3 in parentheses raised to the 5th mean?
You put 1 over 3 to the 5th.
No, it's not a negative exponent. You're trying to make a negative exponent.
Yeah.
Negative 3 to the 5th. When there's parentheses involved means, if we're doing this out by hand, what mathematically am I doing?
Negative 3 times negative 3.
Okay. Negative 3 times negative 3. I don't know. 5 negative 3s, yes? Now, in this case, that would result in a negative whatever the number is. What's the difference over here when there's no parentheses? It's the negative of 3 to the 5th. What's that mean?
You take 3 to the 5th and then you just make it negative.
Yeah.
Like my negative 1.
It's just a negative of whatever 5 3s are. Okay? And so what that means, this one, B, it doesn't matter your exponent. It's going to be a negative answer. A, if your exponent's even or odd, makes a difference here. Okay? So a little bit of review there. Okay. Example A here. 2a b to the 3rd times 5a to the 2nd b to the 5th. I'm jumping right in. Nothing easy. What does that multiply out to be?
A big long thing.
Not that bad.
10a to the 3rd, b to the 5th, b to the 8th.
Agree, disagree?
I agree.
Whole numbers? 2 times 5 is 10. We have an a to the invisible 1 and an a to the 2nd. When you're multiplying like that, you keep the base and add the exponents. And then b, we have a b to the 3rd, b to the 5th. Keep the base and add the exponents. Old news, but we need the reminders. Or maybe you guys are bored out of your gourds. I don't know. Okay. Thoughts on how you want to do B?
First, you subtract them, and then you simplify it.
Okay.
Adjust it.
So this last one we are multiplying. So we kept the base the same and we added. This one we are dividing. So keep the base the same and subtract. And I know the u's and v's look alike, but so this is going to be u to the what?
Third.
2 minus negative 1, which is 3. V to the what?
Negative.
Negative 2 minus 3 is negative 5. If we're going in proper most simplified form, do I get to leave it like this?
No.
No, because we don't get to leave
Negative X.
negative exponents. So, u to the third, it's good, right? It's already positive. Okay, so it's just going to stay. What about v to the negative fifth? Yeah. So it moves to the denominator, right? And we think of it as 1 over v to the fifth. This was u to the third. If I put those together as one fraction, we're going to think u to the third over v to the fifth. Okay, so basically positive exponents stay on top, negative exponents move to the bottom to become positive. So u to the third over v to the fifth. Okay. C, x squared over 2 raised to the negative third. Do we know the trick of how to deal with a negative exponent on a fraction?
Just leave it blank.
Just leave it blank? No.
Just take this.
We're not taking the lazy way and just skipping the problem. Well, what negative exponent end up doing?
Move to the denominator.
Moves it to the denominator, right? What if it's already in the denominator? It moves it to the numerator. So the common shortcut here that you'll see, because I can't do 2 to the negative third power right now. I can't do something to the negative third power as easily. The shortcut you'll see is it will often say, well, this is 2 over x squared. And now, since I flipped that, it's going to be raised to the positive third. Now, if you don't like that, could you have thought of it as x to the second raised to the negative third over 2 to the negative third, and then you'd have to flip them? You could. There's a couple different ways we can think of it. Regardless, that power of 3 has to go with both. So on top, 2 to the third. On bottom, x to the power raised to a power. Just base of x, you multiply. 2 to the third over x to the sixth. I want you to go one more step. X to the sixth I like. 2 to the third is 8, if you do your math correctly. Common wrong answer would be 2 to the third is 6, but you're just being silly there. Okay. D. It asks us to expand. A plus 2, and then there's a x outside. How am I going to expand that? What are they wanting me to do?
X, A plus 2X. Distribute basically.
Okay. That x out back, it's just like it being out front. When they say expand that, they're wanting us to take the x and distribute. What is x times a? Ax, or xa if you prefer, but I like ax. Carry down the plus sign. What is x times 2? 2x. What is ax plus 2x?
Your answer.
Okay, a trick question, right? Not like terms, so I can't put them together. E says factor.
So
Now-
two rounds.
What?
So do the opposite.
Okay, do the opposite. Realize that is 3y minus by. And what can I factor?
Y.
There's a GCF, remember greatest common factor of y. If I put the y out front, what's in parentheses? 3 minus b. That's some basics, but they're coming back to you, right? Okay, one last section. Let's talk scientific notation. And I know you guys have done lots of scientific notation over the years. You have your way probably. That's fine, okay? As long as you know what you're doing, that's fine. Now, I am going to challenge you that we can, for the most part, do C without a calculator, so we're going to talk about that one. But A and B is more of a, how do we convert? 2.375 times 10 to the 8th. What do we want to do? What does that exponent of positive 8 tell me to do?
Move decimal point to the right.
Okay. A positive exponent on your 10 tells us to move it to the right 8 places. Is that adding 8 zeros?
No.
Am I going to add 8 zeros?
I'm down to.
I mean, you can, but you're not going to hit it right. You're moving the decimal right 8 places. In this case, I already had 3 decimal places, so I'm going to end up adding 5 zeros. So 2, 3, 7, 5, 0, 0, 0, 0, 0. Do me a favor. Don't leave your answer with 2 decimals in it. Okay, that drives me crazy. Don't leave your answer with 2 decimals in it. Write it nicely. If I even put commas in there, commas go 3 from the right. Or every 3 starting from the right. Okay, and by the way, if this had been negative 8, that means my decimal would have gone 8 left. Okay, B. 0.000000349. I want it in scientific notation now.
You would count how many you have to go over to make it 3.949. So it should be 7.
Okay.
So you do 3.49 times 10 to the negative 7.
Okay. So first of all, why 3.49?
Because
That's just how it is.
a nice decimal.
Okay. Because it makes a number between 1 and 10 is what I'm going to say. In other words, not 34.9, not 349. You're making a decimal between 1 and 10. And then you are looking at how many place values there are between 1, 2, 3, 4, 5, 6, 7. So numbers between there. There's 7. What makes it negative 7? Because I heard negative.
You have to go to the left instead of the right.
Okay. I'll be honest, I don't think left and right here. He's got it for himself. That's great. I think it was a small number. It was less than 1. It was a decimal. Those are negative exponents. As opposed to a big number bigger than 1, those are positive exponents. But you do you. Okay, however you remember it. Okay, now, I'm going to challenge you that C, we don't really need a calculator. I mean, there's one small part we might put it in the calculator, but this problem is in what section? This is in a scientific notation section. So, let's start off changing each of these to scientific notation. 370,000, what do you know?
3.7.
Okay, 3.7 times 10 to the 5th?
Yeah.
4,500,000,000.
4.5 to the
Right.
Okay. 4.5 makes a number between 1 and 10. There are 9 spots between the decimals. Divided by, what's 18,000?
8 times 10 to the 4th.
Okay. Now, we don't get to stop here. We're going to do a little bit. Look at the numerator with me. How can I multiply that numerator? Okay, kind of a like terms deal. In that, the initial number times the initial number. What is 3.7 times 4.5?
Without a calculator.
This is the part that I'd say put it in the calculator to save us time.
16.65.
16.65. Times, now this is without a calculator. What's 10 to the 5th times 10 to the 9th?
No, 14.
When you're multiplying, keep the base the same, add the exponents, right? So it's exponent rules. And it's still divided by 1.8 times 10 to the 4th. Do you see the direction I'm going to take us now?
That's your answer?
Nope. Now, you're dividing scientific notation. So kind of like how we multiplied the like pieces, now we're going to divide the like pieces. 16.65 divided by 1.8. That's where I'd say use the calculator again.
9.25.
10 to the 14th divided by 10 to the 4th.
10 to the 10th.
Subtract, base are the same. You're dividing, so subtract 10 to the 10th. Is this in scientific notation?
Yes.
Yep.
Yes, because 9.25 is a number between 1 and 10. Could we have stopped with 16.65 times 10 to the 14th as a final answer? No, because that 16 makes it not in scientific notation. Okay. Open your books to page 9. A couple of things to make sure we understand. What are we laughing about?
Because I have a feeling a lot of us did the wrong.
Okay, that's one of the things I need to make sure and clarify. Okay? So first of all, I usually put the starting page number. Okay, so if it says page 9, does that mean all your homework is on page 9? Not necessarily. Okay, I put the starting page number. So this homework starts on page 9. Now, unfortunately, it sounds like some of it did the wrong number 2. So there's often something called a quick review. Now notice on the quick review, it only goes 1 through 10. That's your clue that that's not the right set of numbers. So you're always going to start where it says exercises. Okay, so it's kind of like that burgundy color. So it's always going to be kind of the second set. And if you follow exercises, I mean, there's 1 through 28 on that page, but it keeps going 29 through 65 on the next page and 66 through 76 on the following page. So it keeps going. Those are the numbers you want to do. So you're going to start down there. Your first problem, number 2, is 1599. You're doing something with. Okay, so 2 through 22 evens, 37 through 40 all, 43 to 44 all, and then 48 to 64 evens. I think it's probably like around 30 problems, and a lot of this stuff is review.
You said you just come around and check this.
Yes, this will be, so tomorrow at the beginning of class, so here's the deal. Savas, you didn't necessarily have done when you walked into class, did you? Okay? You need to have this done when you walk into class. Okay, so work through every problem. I did think you could run into a question or something. Of course, I'm always available during homeroom and stuff, but you could also wait during class. And then beginning of class, I will put the answer key up on the board, and I'll walk around and look at your papers. Okay? Let's see. Grab.
No.
Other things.
No, say which property.
Watch the directions. Whether it says write an inequality, describe, graph, use words. Biggest thing I can say is watch the directions. Do remember I mentioned on day 1, this is a textbook, so the odds are in the back of the book to check against. So that's always kind of am I doing this section right? That's a good thing to check. Okay. Not quite as much work time as I hoped, but there's some.